All right, starting lesson 4.8a, applications and models. All right, example 1, solve the right triangle. Okay, solving a right triangle means to find all the missing parts. So for example, we're missing angle B, we're missing A, and we're missing C. We have to find all those parts, and once we do that, we've solved the triangle. What is the altitude? Altitude, that simply means height of the triangle. Okay. So first thing we're going to do is figure out the missing angle. What do all the angles of a triangle add up to? 180 degrees. All right, so measurement of angle B then will be 55.8 degrees. All right, that's one piece. Now we'll use this angle and we'll apply trig functions to that angle. So this would be the opposite side. This is the adjacent, and that's the hypotenuse. All right, so I'm going to find the opposite side, and so I'm going to write tangent of 34.2 degrees is equal to A over, which is your opposite, adjacent, which is 19.4. Okay, let's isolate A. All right, and A is equal to, working this out on your calculator, make sure your calculator is in degree mode, 13.8. And this actually represents your altitude. Or in other words, your height. All right, same thing. All right. Now to figure out C, we'll use cosine. So cosine of 34.2 is equal to 19.4 over C. All right, so I'll multiply by C on both sides. And so I have C times cosine of 34.2 is equal to 19.4. And then we divide by cosine of 34.2. All right, so we get C is equal to 23.46. All right, there we go. We're done. We've solved the triangle. Let's go on to the next example. All right, we have a building. Safety regulation states the maximum angle of elevation for a rescue ladder is 72 degrees. All right, 72 degrees. Angle of elevation. The fire department's longest ladder is 110 feet. 110 feet. What is the maximum safe rescue height? All right, so they're asking you to figure out this height. Or in other words, figure out A. Okay, so based off of this angle, this is my opposite, this is my adjacent, this is my hypotenuse. I want to find the opposite. I have the hypotenuse. I'll use sine, so sine of 72 degrees. All right, is equal to A over 110. So just multiply by 110 on both sides. And A is equal to 104.7, in this case, feet. All right. If there are no units there of measurement, just say units. All right, going on to example 3. All right, at a point 200 feet from the base of the building, all right, 200 feet from the base of the building, the angle of elevation to the bottom of the smokestack is 35 degrees. Okay, bottom of the smokestack. That's 35 degrees here. All right, and whereas the angle of elevation to the top is 53 degrees. All right, this is 53. All right, now find the height S of the smokestack. All right, we need to figure out this height here. All right, let's see, how are we going to do that? Well, notice that I have two triangles here. There's one, and there's another. All right, if I could figure out this height, then subtract it from this height, then I'll get the length of the smokestack. All right, so let's see. I have one triangle at the 35-degree angle. So tangent of 35 degrees is equal to A over 200. All right, that's simple. Multiply by 200 on both sides. So then A is equal to 140.7 0.04. All right, that's an important piece of information. Then we have tangent of 53 degrees is equal to 140.04 plus S. All right, because I just figured out that this is 140.04, and then I'm adding on the S, and that gives me the full length. All right, for this triangle. All right, and that's over 200. All right, I'm a little squished here, so multiply by 200 on both sides. All right, so I have 200. Tangent of 53 is equal to 140.04 plus S. And then I subtract 140.04. And I get S is equal to, if I work it all out, 125.36 feet. All right, so that's all there is to it. All right, so just notice that you have two triangles here. All right, once you find one variable, it's pretty easy to find the leftover one, which is what you're looking for. All right, and all right, last idea. All right, refreshing your memory here. X squared is equal to 4. To get x by itself, you simply take the square root of both sides. All right, and then you've isolated x. Now, here we have sine of x is equal to 1/2. Now, how do you get the x by itself? That's your angle measurement. Well, this is where the inverse sign comes into play. All right, if I take the inverse sign of both sides, essentially you could think of it as it cancels out the normal sign on the left side. All right, and you're just left with the x. All right, and then on the right side you're going to have inverse sign of some fraction. All right, so example 4 says the swimming pool is 20 meters long and 12 meters wide. 20 meters long, 12 meters wide. Well, this isn't three-dimensional. Maybe we'll worry about that later. The bottom of the pool is slanted so that the water depth is 1.3 meters. At the shallow end, it's 1.3 meters. And 4 meters at the deep end. All right, so this is a total of 4. Find the angle of depression of the bottom of the pool. Okay, angle of depression means you're starting at a horizontal line and then you're rotating downward. All right, elevation is going up, depression is going down. Okay, so what are we going to do here? Let's see. I'm trying to figure out this angle. I'll call this x. I have the opposite side. I don't have the hypotenuse. I have the adjacent. The adjacent's 20. Okay, so I could use tangent. All right, so I have tangent of x. Could also call this theta. All right, x or theta, whatever you want to call it. I'll just call it theta now. Is equal to opposite. Don't put 4. It's just this little piece here for the triangle, all right? 2.7 over 20. All right. And now to get theta by itself, I take the inverse sine of both sides. All right. Actually, let me just rewrite this out. So it looks nice. All right, taking the inverse tangent of both sides. All right, what happens on the left side? Regular tangent's gone. You're left with theta. You've isolated it now. You take the inverse sine of 2.7 over 20. Okay, and now this is the power of the inverse tangent. By using the inverse tangent, you will acquire an angle measurement. All right, there we go. There's our theta. Angle of depression is 7.7 degrees. So the most important thing to understand from this lesson is that for regular trig functions, you're finding ratios or fractions. For inverse trig functions, you'll be finding angle measurements. All right, so that's a tool to keep in your pocket. Whenever you're trying to find an angle measurement for a right triangle, you could use the inverse trig functions. If you have any questions, if you need any clarification, please make sure to ask for help. Begin the assignment at the bottom of the webpage.